Hi, I'm Cheryl Leach. In this problem, we're going to be looking at an application from economics called the propensity to consume. Well, what exactly does that mean? Well, for different income levels, it's very possible that you will need to use all of your given income to provide for necessities, food, housing, clothing, things like that. However, as you begin to earn more money, you can use less and less of that percentage of your total income on those necessities. You have some money left over for savings and for some non-essential items. So in this problem, we're going to be looking to find the amount of money that we're going to be using strictly on those necessities. So what I've been given is the marginal propensity for consumption. So in order to evaluate Q, I need to integrate. So I know that Q is going to be equal to the integral of dq dx times dx. Well, I know what that marginal propensity is, so I'm just going to substitute it in. 0.95 all over x minus 24,999 raised to the 0.05 power dx. In this particular problem, I also notice that x has to be greater than $25,000. That's telling me that if I'm earning at $25,000 level, that I will use all of my income for those basic needs. So let's go ahead and get back to the integration problem. This is fairly complicated, and I have x's in my denominator. So the first thing I'm going to do is move it up to the numerator and write this as 0.95 times my quantity raised to the minus 0.05 power dx. And now I'm going to need a little substitution to help me with this. And as always, the substitution I'm going to use will be the inside function. So when I use that substitution, I'm going to say that u is going to equal x minus 24,999, which means that du dx is just 1. And if you prefer, you can write this as du equals dx to show the relationship between du and dx. So now when I rewrite my integral, I can write it as 0.95 u to the minus 0.05 power, and dx and du are exactly the same thing. So now I have a basic integration problem. I can pull out the constant 0.95 and integrate u to the negative 0.05 du, adding 1 to the exponent and dividing by the same number. So that'll be u raised to the 0.95 all over 0.95 plus my constant of integration. Notice that 0.95 cancel, and I'm left with u raised to the 0.95 power. Well, integration's done, so I can actually substitute my u value in at this point. So I'll have x minus 24,999 raised to the 0.95 power plus my constant. Well, I'm almost there. What I need to figure out is that constant. Well, I know that if my income is $25,000, I'm going to have to spend all $25,000 on my necessary items. So that tells me that Q of 25,000 equals 25,000. So if I plug 25,000 in to my function, I should get 25,000. This luckily reduces all down to 1. So 1 plus C is 25,000, which means that C is 24,999. So my overall function is going to be x minus 24,999 raised to the 0.95 plus 24,999. So Q, remember, tells me how much money I'm going to need for my necessary expenses. For the next part of the problem, we're going to look at a numerical representation of this information. We're going to do that by using a table. You can either use a spreadsheet, or graphing utilities often have table functions on them as well. So let's go ahead and look at an input of your income. So we're going to take a look at the case where your income is $25,000, $50,000, $100,000, and $150,000. So I'm going to go ahead and use my graphing utility to enter in my function Q, which will give me the income that I'm consuming for those necessary items. So I enter that into my calculator. I've got x minus 24,999 raised to the 0.95 plus 24,999. Then I can also enter x, which is my income, minus this value. So I'll enter x minus my function that I just entered. Now when I go to the table feature, I notice that I can enter all of my given inputs. So let's see what happens when I earn $25,000 a year. If I enter $25,000, I notice that the amount of money that I consume is also $25,000. And the amount that I have left over is going to be 0. Let's do this again for $50,000. I'll enter $50,000 as my input, and I notice that I now have $40,067 that I'm spending on necessary items. And I also have $9,933 that I have to spend on extra items. Again, we'll repeat the process for $100,000. So I'll enter $100,000 into my calculator. That tells me I have $67,786 that I'm consuming on necessary items and $32,214 for those extra things like savings. One more time, enter $150,000 for my income. And I notice I have $94,512 for necessary items, and I have $55,488 remaining for extras. All right, so now I have a numerical sense of what's going on. Let's go ahead and look at it graphically. Well, I already have my equation Q entered in on my calculator. Okay. So I would also like to enter an income function. And I'm going to do that by simply entering y equals x. Okay. Now, these are some fairly large numbers that I'm working with, so a standard window is not going to be appropriate. So what I would suggest is let's use the minimum x value to be 0. The maximum, we're going to use 150,000 because that was my income, and on my table, I went the whole way to 150,000. And for a scale, a nice scale would be to use 25,000. Now we have to look at our y values. What are the lowest and the highest y values we want to use? Well, again, I think I'm going to start at 0. But then when I look at my table, I notice that for my Q value, the highest value I had was around 94,000. So I'm going to go the whole way up to 100,000 to make sure I get everything in the window. And again, for a scale, let's use 25,000. Okay, so now when I graph my functions, I'm going to notice that I have two lines, and they basically look like a Y. The lower branch is going to represent this function. The higher branch is representing my income. So at any income value, I can go ahead and read off on that lower branch what amount of money I'll need to spend on my necessary items. If I go to the upper branch and look at the difference between the two, that will be the money that I've saved and I can use on extra items. One more thing I should probably point out. Even though our graph looks linear, our function q is not really aligned. But if you notice, this exponent is so close to 1 that at the part of the graph that we're zoomed into, it's going to look very linear. I hope this is helpful. Thanks.